Hello, everybody. This is a talk about the Fresco project evaluation presented by me, Alessandra Zanazzi, and my colleagues Stefania Varano, Silvia Casu, and Sara Ricciardi, all of us from the Italian National Institute for Astrophysics. I will introduce the project. Stefania will talk about the research questions. Silvia will describe the evaluation tools we used, and Sara will talk about the very preliminary results. Very preliminary because Fresco is a project still ongoing, and it's a project promoted by the Office of Astronomy for Education Center Italy to co-design playful resources for children up to 12 years old, building on previous co-design experiences that the OAE Italy had in the Mediterranean. We decided actually to expand beyond the Mediterranean and involve a larger community and focus on innovative children-centered educational practices like playful learning and game-based learning, because we have gained quite an experience in these fields and found that these kind of methodologies could be really powerful and effective for the learning experience, because kids actively participate in their own learning. So we issued a call for all NAICS worldwide, and we had a group of 10 participating countries that answered to the call. And these are the countries that are included in the project. To set a common base of understanding for our future work, we decided to share 2 seminars given by experts in the 2 fields, in the 2 methodology, and so that we could define what we intended by playful learning and game-based learning. For example, not instructional activities for playful learning, but activities in which kids are free to explore and be creative, and not gamification, but games where the learning comes from the mechanics and no previous knowledge of the subjects is needed for enjoying playing and for participating. Also, after the first meeting to discuss and share the proposals, we decided to split in 2 groups, one dedicated to the design of game-based learning activities and the other 2 playful ones. We had online meetings from May to October, and we managed to carry out the real co-design work with the collaboration of our different approaches and different minds. And also, all the activity that we designed started from scratch, because actually the proposals were so different that we couldn't choose, and we decided to start it from zero. And also we had more than 10 online work meetings, despite participants, especially from countries such as Syria and Lebanon, were sometimes suffering connection difficulties due to the terrible situation and the attacks in their countries. These also reflected in a reduced participation in the in-presence residency that took place on 13 to 16 October in Istanbul before the Mediterranean Regional Shaw-IAU Workshop on Astronomy for Education mastered. During the residency, we worked in present for 3 days and were able to make a huge leap in finalizing the process and the activities. In the end, we were also able to preliminary test the activities with the mastered people, with a larger audience. Now we plan to keep on meeting online with the participant in Fresco in order to conclude and fine-tune the activities and to publish the resources that we have co-designed.
The evaluation presented here aimed to assess participants' perceptions on their personal experience of co-design and their views on the value and effectiveness of such a process. The evaluation of the Fresco co-design process was ongoing and somehow also iterative, since we were aiming at spotting and assessing possible changes in the participants' feelings and perspectives about the co-design they were experiencing. The main research questions that drove our evaluation were: Are participants feeling comfortable in the co-design process? Were they expecting something different? Is the process changing their perspective in any way? And then, is the process perceived as effective in producing somehow better resources than the ones that could have been developed separately? In order to fix at zero of our evaluation, we designed a way of assessing the initial status of our community concerning our research questions. One thing was to assess the previous beliefs about what the co-design was about to be. The second important assessment was aimed to highlight the expectations about how this process would have changed in any way the initial proposed activities used as a starting point for the whole process. Here you can see some of the answers to the question, what do you hope to achieve to this co-design process that we extracted from the forms of participations to Fresco? During the co-design process, we continuously kept an eye on the fact that the activities that we were designing were coherent with the definition of game-based learning and playful learning collectively agreed upon. To do so, at first we had to assess participants' initial knowledge of game-based learning and playful learning, about their nature and the aims of these methodologies. In particular, we hoped that all participants had comparable acquaintance with the methodologies we were about to implement in our co-design. And so we checked this during our very first call for proposal, in which we asked why using game-based learning and playful learning. And then we asked that again during our first online meeting, and here are some of the answers on this theme. We tried to assess this inference without being interrogative or demanding, because our aim was to effectively facilitate a process of community knowledge and experience building without being instructional. Since the participants declared that they had no extensive experience in the proposed methods, the offered seminars that you heard about were a good way to set a common base. The evaluation of the final product was not the focus of this work. It was foreseen as a separate and subsequent step to be done with different communities, namely group of students experiencing the activities in their classrooms in the different participating countries.
Fresco project involves many people who didn't know each other initially and involves a working method, co-design, and a methodological approach, game-based and playful learning, that are not universally acknowledged. Evaluation such a process is not a simple task. We therefore design an evaluation plan in collaboration with an expert in assessment, Sophie Bartlett, from the Office of Astronomy for Education. We identified different evaluation tools depending on different aspects to be evaluated. The final decision on the most suitable tools was obviously influenced by the working strategy, purely online through its initial phase and in presence only in the last few days during the Istanbul residency. To gather evidence and data on our co-design process, we hence use the following tools. The surveys on pre-existing knowledge on the process and educational methodology. We use cumulative online Jamboards to collect disciplinary aspects proposed by participants, previous ideas and preconception on methodological aspects, and fundamental values on which to base the educational action. The survey was very useful to understand the initial level of confidence and or the experience of participants on GBL and PL, and build a shared perspective. To assess the changes in participant feelings, perceptions, knowledge, and expectation before, during, and post the process, we use the tool of a reflective journal. We distribute 4 online questionnaires to the participants with different questions. Some of them repeated, comfortable feelings, inspiration, changes during the process. The main idea was to encourage the self-reflection and to identify strengths and area of improvements. During all the phases, both online and in presence, we recorded the sessions and took notes to evaluate several aspects of the process, such as team dynamics, the flow of the collaboration, decision-making processes, and any possible disagreements between the participants. Finally, in order to gather qualitative insights on the participant experience, in particular network community building efficacy, collaboration, challenges faced, process efficiency, feasibility and replicability, we dedicate a final session, only 1 hour long due to the necessity to let space to the final part of our in-person interaction and work, to a focus group with all the participants. We started the open discussion from the following questions, and we recorded all the audio interviews.
Since at the time of this video recording we just finished the Fresco residency, we can share only very preliminary results. The atmosphere in the online meetings has become increasingly positive and effective, and the in-person residencies has certainly made everything easier, smoothing out some rough edges we encountered along the way. A key challenge that emerged over time is the efficiency of this process, which required patience and time for results to fully materialize. In the early stages of the co-design process, some participants felt overwhelmed by the variety and richness of the proposal, expressing doubts about the potentiality of the process to produce an outcome. Some participants also shared with us that they had to make several compromises on their initial idea to create a shared collaborative product. As we approached the final stages, just before the residency, participants reported that meeting by meeting, the product was becoming more concrete, thanks to the impressive work group and the rich exchange of ideas amongst all. These collaborative dynamics allow for gradual emergence of a shared vision. One participant diary entry particularly stands out, capturing the general feeling of the group during the closing of the online session. I'm happy that we are getting somewhere. In the last round, we developed a draft of the final game and felt confident we can really do it. Co-design needs time and patience, but it's a great way to exchange ideas and learn from each other. This reflection embodies the spirit of the co-design. It may be a slow and at times uncertain process, but it fosters a collaborative environment where participants can learn, evolve, and ultimately create something meaningful for everyone. We hope Fresco members will bring the same spirit to their national community of teachers and students to open up for shared, playful, and creative learning. We report a very significant entry of one of the reflective journals. As a matter of fact, not only my ideas are changing, my way of thinking, the way I research for certain definition and topics, the way I discuss with my group members, and the way they and I convince each other. This co-design was a wonderful experience for me to develop and grow. So yes, a change for the better and for the more collaborative approach. In addition to this openness to the co-design process, participants also recognize an intrinsic value to this method with respect to the educational design itself, devoted to playful learning and game-based learning approaches. Yes, of course, there is a considerable change in my initial idea. I improved the initial proposal based on the input from different colleagues, and still, the second version needs new improvement based on the new input. Thanks to this co-design meeting, I learned a lot about educational game design. So for now, that's all. Thanks everybody to be with us today. We will publish soon our results on Astro-IAU, and we will also share final results in future occasions.
El mundo es gigantesco, el universo es infinito y nosotros les enseñamos a nuestros estudiantes sobre esa inmensidad desde un salón de clase. Siempre desde un salón de clase. Pero ¿qué pasaría si nosotros lleváramos esas enseñanzas más allá de las cuatro paredes? Un saludo a todos. Mi nombre es José Antonio de Santiago García. Soy profesor de ciencias de la Universidad Nacional Experimental Rafael María Baral, Mene Grande, Venezuela. Hoy quiero compartir con ustedes cómo he transformado la enseñanza de la astronomía con mi proyecto de investigación, el cual lleva por nombre el título de esta charla de hoy: Evaluación del aprendizaje en astronomía, métodos y herramientas en el contexto del aula invertida y el peripatetismo astronómico. Cabe resaltar que estas metodologías han sido implementadas en nuestro club de astronomía, el cual lleva por nombre AstroSí, y fue fundado hace 1 año y medio y nos ha servido como un laboratorio para comprobar que estas metodologías son sumamente efectivas. Este trabajo explora una propuesta innovadora de evaluación del aprendizaje en astronomía, combinando las metodologías del aula invertida y el peripatetismo astronómico. Se implementan diversas técnicas de evaluación, incluyendo evaluaciones formativas, sumativas, observaciones en vivo y discusiones interactivas. El objetivo es medir la efectividad de esta metodología en la comprensión y retención de conceptos astronómicos por parte de nuestros estudiantes. Los datos recopilados muestran que los estudiantes no solo mejoran en sus evaluaciones teóricas, sino que también demuestran una mayor capacidad para aplicar sus conocimientos en situaciones prácticas y reales. Esta combinación del aula invertida con el peripatetismo astronómico ha sido muy efectiva. ¿Qué es el aula invertida? El aula invertida es un enfoque innovador. Esta metodología ha ganado popularidad en las últimas décadas como una forma muy efectiva de enseñanza. Esta técnica invierte la estructura tradicional del aula, donde los estudiantes adquieren el contenido teórico en casa a través de videos, lecturas y recursos digitales, y utilizan el tiempo de clase para actividades prácticas y colaborativas. Esta estrategia se basa en la premisa de que los estudiantes aprenden mejor cuando tienen la oportunidad de interactuar y aplicar sus conocimientos en un entorno práctico. Este es un enfoque holístico en la enseñanza de la astronomía, ya que tradicionalmente el aula invertida se centra en la adquisición de conocimientos teóricos en casa de los estudiantes, reservando el tiempo presencial para actividades en un aula física tradicional, donde se discuten, debaten y aclaran dudas. Sin embargo, lo innovador de mi propuesta es que el tiempo presencial no se lleva a cabo en un aula tradicional, sino al aire libre, donde el peripatetismo astronómico cobra vida. Este cambio transforma el enfoque educativo, permitiendo a los estudiantes observar el cielo nocturno en tiempo real y aplicar los conocimientos adquiridos en casa en un contexto práctico y envolvente. ¿Qué es el peripatetismo astronómico? El peripatetismo es una herencia de la antigüedad. El término peripatetismo proviene de la filosofía de Aristóteles, quien enseñaba a sus estudiantes mientras caminaban y discutían al aire libre. Este enfoque pedagógico enfatiza la importancia de la observación directa y la interacción con el entorno. En la antigüedad, el peripatetismo no solo era una forma de enseñanza, sino también un método para fomentar el pensamiento crítico y el debate entre los estudiantes. Aristóteles creía que el aprendizaje se enriquecía al experimentar el mundo directamente, lo cual es esencial en el estudio de la astronomía, donde la observación evidentemente es fundamental. El peripatetismo astronómico es una innovación de nuestro club. El término peripatetismo astronómico fue acuñado para esta metodología por mi persona, reflejando así la combinación de la tradición de enseñanza peripatética con el estudio de la astronomía. Utilizando el cielo nocturno como nuestra pizarra, los estudiantes pueden observar fenómenos astronómicos en tiempo real, como las constelaciones, los planetas y otros cuerpos celestes. Este método no solo fortalece su comprensión teórica, sino que también genera un sentido de asombro y conexión personal con el cosmos. El uso del cielo nocturno como nuestra pizarra y la naturaleza como nuestro salón de clase permiten a los estudiantes vivir la experiencia de la astronomía de manera inmersiva. En lugar de limitarse a la teoría en un aula cerrada, en un aula tradicional, los estudiantes se convierten en exploradores observando y discutiendo lo que ven en el cielo. Este enfoque promueve un aprendizaje activo y participativo, donde el entorno natural se convierte en un recurso educativo invaluable. La evaluación se lleva a cabo en dos niveles, formativo y sumativo, proporcionando una visión integral del progreso de los estudiantes. Las evaluaciones formativas están compuestas por cuestionarios en línea como Kahoot, Google Form. Antes de las sesiones prácticas, los estudiantes completan cuestionarios que cubren los conceptos estudiados en casa, lo que permite identificar dificultades y ajustar las actividades. Tenemos, por supuesto, observaciones en vivo. Durante las caminatas y observaciones nocturnas, los instructores realizan observaciones en tiempo real, evaluando la participación y comprensión de los estudiantes, proporcionando de esta forma una retroalimentación inmediata. Tenemos discusiones en grupos. Las discusiones grupales que siguen a las actividades prácticas fomentan el aprendizaje colaborativo y el análisis críticos. Las evaluaciones sumativas están compuestas por exámenes escritos. Al final de cada módulo, los estudiantes realizan exámenes que miden su comprensión teórica y capacidad de resolver problemas astronómicos. Tenemos proyectos prácticos, donde los estudiantes aplican sus conocimientos en proyectos que vinculan la teoría con la práctica. Ellos tienen un portafolio de aprendizaje. Los estudiantes mantienen un portafolio que se evalúa periódicamente, donde documentan sus avances, reflexiones, trabajo práctico, diarios de campo. El análisis de los datos obtenidos revela que estas metodologías tienen un impacto positivo en varias áreas clave, como la mejora en las evaluaciones teóricas. Los estudiantes muestran una mayor comprensión de los conceptos astronómicos. Tenemos aplicación práctica. Las actividades prácticas le permiten aplicar sus conocimientos en situaciones reales, mejorando de esta forma sus habilidades de pensamiento crítico. Hay una mayor motivación y participación por parte de los estudiantes. Han perdido el miedo a la hora de participar. La combinación del aula invertida con el peripatetismo astronómico ha demostrado ser una estrategia educativa efectiva que favorece tanto el aprendizaje teórico como la aplicación práctica de los conceptos astronómicos. Al trasladar el aprendizaje a un entorno real bajo el cielo nocturno, los estudiantes se sienten más conectados y motivados para participar activamente en su educación. Para finalizar, de manera reflexiva, les traigo este breve comentario. ¿Cómo le vamos a enseñar a nuestros estudiantes sobre la inmensidad del universo si no salimos del aula de clase? Muchísimas gracias por escucharme.
My name is Oriel Marshall, and I'm a PhD student at the universities of Copenhagen and Antwerp. I'm a member of the Chameleon Research Network, and this is a research group that looks into exoplanets, climates, and atmospheres, and modeling those computationally. So what you can see here are, on the left is an image of a climate model of an exoplanet showing where clouds would be likely to form. And then on the right is a map of a simulated Earth-like tidally locked planet showing where lightning would strike on this planet. And so clouds and lightning are two weather phenomena which are fascinating, especially within the context of planets outside of our solar system. And so what they're focusing on the network is creating these models of them. And so what I wanted to do with my research project, which is a interdisciplinary astrophysics and education project, is I wanted to look at looking at other ways of modeling these phenomena that can be used in the classroom that students can then use to talk about and learn about these topics. So because the computational models, I mean, these are whole PhD projects worth, so we found something that was a bit more appropriate for the classroom. And we developed these sets of materials. So if you want to hear more about the development of these, there's another talk in a different session where I talk about the process of developing these. But so we have two different ones. The one on the left here is showing lightning. So it's using triboelectric charging and like static electricity to demonstrate lightning. And then the other one is creating a cloud in a jar where you use hairspray and water to show cloud nucleation within a jar. One of the important things to note here, just for practical reasons when we're discussing it later, is that the clouds are formed in the jar, and before you form the clouds in the jar, you wipe a bit of like washing up liquid around the inside of them so that it doesn't fog up on the outside, so you can see the cloud itself more clearly. Why I'm mentioning this will become clear later. So you can see I've got these two experiments, and these both represent cloud formation and lightning formation on an exoplanet. And so now to bring you to what we're actually doing with these in my current study. The research question we're looking at is, in which ways do students utilize student-led hands-on experiments as an analogy during post-lesson discussion? We'll break this down as a parts throughout this talk, just so that we're all on the same page and we can understand it thoroughly. So what we talked about just previously were these student-led hands-on experiments. The student-led there is that these are part of inquiry-based lessons. Yeah, the experiments are what I just explained to you. But next up, I want to talk about what I mean by analogy in this setting. We're going to jump briefly to a bit of theory. So talking about conceptual metaphor theory. And so in this case, conceptual metaphor theory is this idea that you can have a metaphor by you can construct a metaphor by having a base domain or a source domain, which is concepts or ideas that a student already has access to, and then a target domain, which is a topic or subject that you want the students to be able to understand. So let's take a basic example of, say, life is a highway. The base domain there is a highway, and you're expecting that people know certain things about a highway. And then the target domain there is life. So you expect them to map certain aspects of the base domain. So say, for example, a highway takes you on a journey to the target domain of life, which takes you on a journey. Now, what we're using here is physical analogies, which is a multimodal instance of these conceptual metaphors. So we're using as the base domain an experiment that students can interact with. And as the target domain, we're using a phenomena that we want this experiment to represent. So in our case, we're looking at the cloud experiment and the lightning experiment and how those could apply to exoplanet weather. Feel free to take a moment and just think about, are there analogies that you might use, physical experiments or analogies that you use in your classroom, and how you think students might use those? Okay, I've hopefully got some sort of ideas in your head that will just help as we're going through with this presentation. So we've now understood the analogy part of this research question, and now I want to explain what I mean by these post-lesson discussions. So the way that we set up this study was that we had 28 students aged 16 to 18, and we ran two different lessons. One was about the clouds and one was about the lightning. And the students participated in these lessons, and then after they were over, we split them into 8 different groups. Within these groups, we gave them a set of questions, written down questions, and we asked them to take their time, and they had a camera recording them and a dictaphone, and to talk through those questions. Just, to take their time, and they took all between 9 and 16 minutes. The questions are as follows, where we said, explain what you did in your experiment. Why was each step of the cloud lightning formation process necessary to make cloud/lightning? Explain how you can relate what happens in the experiment to what you see here on Earth, what happens on an exoplanet, how do clouds/lightning form generally, and how do you feel that the experiment changed or added to your understanding of cloud formation? And then, are there any confusing or irrelevant parts of your experiments? Now, the reason that we did these in peer-led groups, so they were just self-led, is partly for practical reasons. There wasn't enough of us, the researchers, to be in all the groups, but also so that they had the freedom to present their authentic opinions. So they weren't trying to please the researchers or the teachers, that if they didn't know what was going on, then they could say that freely to their peers. So we then transcribed these focus groups, and what I'm going to talk through next is some of the themes and the ways in which we found the students using these analogies during these focus groups. So the first one is that students were able to map aspects of the base domain onto aspects of the target domain. So for example, this one conversation, the cold water at the top of the jar could be like the outer atmosphere. Yeah, and the hot water at the bottom could be like the heat from the Earth, like the surface of the Earth is warmer. So you see they're going between mapping aspects of the base to the target. Students identified elements of the base domain that didn't map to the target domain. This is where we come back to the dish soap thing. One of them said, I guess the dish soap is kind of irrelevant to the experiment itself because the only thing it did was help us visualize the experiment. So they realized that that is only part of the base domain, the experiment, and not part of exoplanet atmospheres. Next, we noticed that students were able to switch between the target and base domains when explaining the concept. So the first student says, there are two clouds. One is very positive and one is very negative. This is with the lightning experiment. The other says, no, it was more like they split up, like with the metal container. The bottom got very negative and the top got positive. So you see that one of them is using the target domain, the other one is using the base domain. So they can switch between these when explaining the topic to the other person. And then the fourth one we noticed was that students used the base domain as a reference point to seek clarification in respect to the target domain. So for example, one of them says, I don't know how the hairspray works. So for the cloud formation, you add hairspray. One says, that was the aerosol. Yeah, the little dust stuff. So the dust there is talking about the dust in the atmosphere of a planet, and the hairspray is talking about the domain. So we've split these into sort of two categories, one of them being that students could map and identify. They could identify elements that didn't map, and they could map elements, and that's sort of like internal processing. And then the other two, where they're explaining it to the other person or they're seeking clarification, is when students are kind of using this almost shared language of the experiment to talk about the topic between themselves. So this is something that's more to do with the interaction with other students. And so what we can see here is that not only is using experiments like this, hands-on experiments, a useful way to explore often intangible topics, which astrophysics, as I'm sure everyone in this workshop is familiar with, can be quite intangible and quite hard to figure out how to actually have them interact with it in a more hands-on way. And so experiments like this, students can use these as a way as an analogy to learn more about these topics and to understand them more. And I think in addition to having students use the experiments to understand space, I think that in general, space and, exoplanets, but also just, in general, astrophysics can be a really great application and a way for them to, a way for students to map and expand the things that they've learned about, in the classroom, and see it in a broader context and apply it to this larger sort of context. So that's everything that I wanted to share with you today, and I'm really looking forward to any questions that you have in the post presentation discussion. Thank you very much.
Hello, everybody. Good morning, everyone. I am Cuauhtémoc Méndez, astronomy teacher at Tec de Monterrey Campus Guadalajara High School. And I am glad to tell you today about what we have been investigating and practicing about the engagement of the students in the astronomy course. Well, this image is from an astronomical night conducted by our students in which they themselves explain to their family and friends about what they have seen in the course and what they observe in the telescopes. This is a very popular event among the students of each new generation. Later on, we will talk about the direct relationship that this has precisely with our topic, engagement. I begin by distinguishing engagement from motivation, two concepts that are often confused. For this, an analogy is often used with respect to reading. Motivation would be the interest the student has in reading and the self-perception of his or her reading ability. Engagement would be the number of words the student reads per minute. During the pandemic, while we were looking for literature to help us improve our astronomy course, we came across a very interesting study by Dr. Chris Impey and collaborators. In this study, they conceptualized astronomy course engagement as the fact that performance exceeds 70% of the assigned activities. We at Tec de Monterrey start from this concept to measure engagement with the percentage with which students exceed the passing grade, which is, by the way, 70%. We observe this both in the number of activities performed as well as in the partial and final grades obtained by each student. As an example, we can mention that if a student gets, let's say, 70 points on his or her exam, this means he got 5 out of 30 possible points for engagement, meaning reaching more than 60% of it. Example number 2, if a student gets 87 points in his or her exam or the final grade, this means he got 17 out of 30 points from engagement, meaning more than 56% of it. Example number 3, yes, I'm a teacher. And if she or he gets 95 points of his or her exam, this means she got 25 out of 30 points from engagement, meaning she reached more than 83% of it. Having a concrete measurement for this aspect allows us to evaluate different strategies and activities and to select those that are most relevant to achieve engagement, actually. Among the activities suggested by the literature consulted, the ones that have given us the best results are the following. Lecture tutorials, and here Dr. Slater's team at CAPER has done a wonderful job designing questions and activities that get students to use the concepts seen in class to understand them in a more concrete way. If we just lecture, we would be doing boring sessions and most of the information would be forgotten just in a few days. Further readings, and in this aspect, Sky and Telescope magazine has been doing a very assertive job in sharing versions for students. Having new and attractive content really stimulates reading and thus the curiosity of students. When the teacher is a rock star, this is very important to become engaged, but unfortunately, this is quite complicated here in Mexico. However, we have had the kind presence of personalities who have agreed to join us virtually in some sessions, such as Dr. Chris Packham from University of Texas in San Antonio, Lucinda Offer from the Royal Astronomical Society, Dr. Katie Berryhill, and Dr. Gonzalo Tancredi, among others. It is very important to know that to have engaged students, you really need to have engaged teachers. Of course, stargazing experiences with telescopes. In our course, this marks a turning point in the attitude of students in the course. Most of them are using this kind of equipment for the first time in their lives. And of course, we invite them to use them themselves. This is very, very interesting for them. Family and friends, very important also. The literature mentions that the option that the opinion of the circles close to the students is very important. So we encourage them to invite them to stargazing experiences in which they, the students themselves, explain to their guests what they have seen in the course and thus make them more interesting what they are observing through these telescopes. And undoubtedly, the most important thing is to get the students to do the explaining. This really gives them an active role, not only in the astronomy course, but also in their own education. I have to mention the most important recognition we have received so far in the astronomy course is when the students tell us that in the evenings, at dinner time, the topic of conversation with their families is usually what they are learning in the astronomy class. Thank you very much for your time, and as we say in astronomy, clear skies.